Hello everyone. Myself Pankaj. I am working as a assistant professor in Department of Electronics and Communication Engineering. And today I am going to deliver a lecture on the topic clampers. Okay, this is a very important topic related with diode applications, and we are shifting the level of input by using clamper circuit. So I am sharing my screen and we will discuss how we are going to solve our equations, how we are going to solve the questions related with clamper circuit. Okay, so here I have made three different waveforms. So first, I would like to discuss about these waveforms. Here you can see in first waveform, the maximum voltage is 10 volt and minimum voltage is minus 10. In second waveform, this is 15 volt maximum and minus 5 volt minimum. In third waveform, 6 is maximum and minus 14 is minimum. So we can find the similarity between these three waveforms, that the difference of V max and V minimum is 20 volt in all three cases. So students, this is important parameter, that when we are going to solve our clamper circuit, we have to keep in mind that our output and input will be same in this way, that the maximum and minimum voltage difference will be same of input as well as output. Now the second importance is how we are going to differentiate, how we are going to identify whether the question is clamper circuit, clipper circuit, any other circuit. So I am going to draw a specific circuit and we will clear with the help of that particular circuit. So in clamper circuit, one capacitor will be there, one diode will be there, and there may be or may not be a DC battery. And a load resistance RL is connected across the parallel in diode and DC battery, and we can measure our output across this load resistance. Now we will apply our input across capacitor. So first we will discuss about this circuit and then what methodology we are going to opt to solve this particular question. So important thing is capacitor must be there in any clamper circuit, one diode will be there, and DC battery will shift the input voltage. So by identifying capacitor, diode and DC, we can say this question will be in the category of clamper circuit. So there is fixed rule to solve this particular circuit and we are going to discuss that methodology. So first of all, for any particular circuit, suppose I am taking one example. This is the circuit where the value of capacitor is 10 microfarad, a diode is ideal diode is connected, and a battery of 5 volt is also attached with this diode, and across this load resistance RL and the value is 10 kilo, we are going to find out our output voltage. We are applying our input at this terminal, and suppose the input waveform is a square waveform and having magnitude of 10 volt and minus 10 volt. Okay, so in step 1, this is most important stage. In step 1, we will solve that half cycle first in which diode is going to be forward bias. Means suppose this is the terminal of P-type terminal of diode, and so we are going to solve first half cycle, that will be positive half cycle. So we will solve this for positive half cycle first, then we will solve for negative half cycle. So in positive half cycle, this will be our equivalent circuit, plus minus Vi. this capacitor will store the voltage plus minus VC. The diode will be in forward bias since it is ideal diode. 0 volt voltage drop will be there, and a 5 volt battery is attached with diode. So this will be our first step. We will identify V output, and it is very clear that V output will be 0 volt plus 5, that will be 5 volt. So this will be my output in positive half cycle. Okay, again I am repeating, we have to choose that half cycle first in which diode will be in forward bias condition irrespective of DC battery. So when we are considering forward bias or reverse bias condition, we will not consider this DC battery attached with diode. So it is very clear that P-type semiconductor is connected with positive terminal of the battery. That's why we will choose P-type or positive half cycle first for analysis. So in positive half cycle, we will have plus 5 volt output. Okay, in next step, we will try to find out. This is going to be VI minus VC, okay, and minus 5 volt. This will be equals to 0. So I'm writing here this VC will be again it will be VI minus 5 volt. So with the help of this KVL, we are able to find the voltage across capacitor. Okay, so this voltage across capacitor will remain same when we are going to analyze the negative half cycle. Okay, so I'm making the circuit for negative half cycle. So in negative half cycle, polarity will change. This will be minus plus VI, but the capacitor will maintain its polarity as it is in first half cycle. Okay, and in negative half cycle, this diode will be in reverse bias condition. That is it will be in open circuit condition, and battery will remain same. Okay, so current I through diode will be 0, and again we are having this load resistance RL. Across that we are going to obtain our output. So I will write a simple KVL equation here to V output, and we will get minus VI minus VC is equals to V output. That means V output equals to minus VI, and I am keeping the value of VI. This will be minus plus VI minus 5. This will be minus 2VI plus 5. Okay, and this VI is 10 volts, so 20 plus 5, this will be minus 15 volt. So this will be my output in negative half cycle. Again I am repeating, in negative half cycle this diode will be in reverse bias condition. That is current ID becomes 0. So we will write KVL starting from input terminal to output terminal. So I have written here minus VI plus to minus VC is equals to V output. That is V output equals to minus VI, and I am keeping the value of VC what we obtained in positive half cycle, that is VI minus 5. So it will become minus 2VI plus 5, and the magnitude of VI is 10 volt. So minus 20 plus 5, it will become minus 15 volt. I'm hoping that it is clear to all of you. So by solving these two equations, we will have V output plus 5 volt in positive half cycle and minus 15 volt in negative half cycle. Okay, so I will make a circuit input output voltage diagram. So we are having V input 10 volt minus 10 volt, and after solving the equation we are having output plus 5 volt in positive half cycle and minus 15 volt in negative half cycle. So this is the input waveform, what we have taken in our question, and this will be our output waveform. So it is very clear the difference of V maximum and V minimum is here 10 minus 10, it is 20 volt. And at output also, V maximum and V minimum, this is plus 5 volt minus 15 volt, again it is 20 volt. Okay, student. So this is, I think it is clear that the difference of input and output voltage remains same after solving the clamper circuit. So application point of view, we can say that we can use this circuit as a level shifting. Yeah, level shifter. We can use our clamper circuit as a level shifter without changing the shape of input waveform. Okay. Okay, we will do some more example to clear our clamper concept. So I am taking some another example of clamper circuit. So suppose in circuit 2, I have taken this input waveform that is varying from 15 volt to minus 15 volt. And next circuit which we are going to solve here is like this. Okay, this capacitor is there. Its value, suppose I am taking here 10 microfarad. This is our input voltage which we are going to apply, that is in positive half cycle plus 15 volt and in negative half cycle minus 15 volt. Okay, the suppose I have taken silicon diode here and the DC battery is having amplitude of 4 volt. This is the load resistance RL. Suppose it is 1 kilo ohm resistance, and across the load resistance we are trying to calculate the output voltage. Okay, so as I told earlier, in step 1 we have to choose the diode that half cycle first in which diode is in forward bias condition. So here the n-type semiconductor is in upward direction, so we are going to choose negative half cycle first for analysis. Okay, again I am repeating, we have to choose that half cycle first for analysis in which the diode is in forward bias condition. So this is n-type semiconductor which is connected in upward direction. So I will write here in negative half cycle, this silicon diode will be in forward bias condition. Okay, so I am making the equivalent circuit here. So it will be minus plus Vi. Okay, this capacitor will be charged with minus plus Vc. This silicon diode is in forward bias condition. So the cut-in voltage of silicon diode is 0.7 volt, I have mentioned here, and a DC battery of minus 4 volt is also connected across this. So this will be my equivalent circuit. Here we are trying to calculate the V output. Okay, so simply I will write a KVL here. So this KVL will be minus Vi. Okay, we are going here plus to minus, so this will be minus Vi, then plus Vc. Okay, again here minus to plus we are coming, I will write here 0.7 volt. Again here minus to plus, this will be plus 4 volt is equals to 0. So Vc will be Vi. Okay, this Vi will go this side, this will become plus minus 4.7 volt. Okay, this will be the voltage across capacitor, and obviously we will have V output equals to, we will go from here, this will be minus 4 volt and this is minus 0.7 volt, so it will become minus 4.7 volt. So in negative half cycle we will have two outputs. One, V output is minus 4.7 volt and the voltage across capacitor will be Vi minus 4.7 volt. I think it is clear to all of you. Again, I am repeating, we have chosen here negative half cycle first because For this condition, diode will be in forward bias condition. In step 2, we have calculated the VC as well as V output. So by putting the sign of potential here plus, here minus, again VC will be minus and plus. This cut-in voltage of silicon 0.7. As per polarity, I have kept minus negative terminal upwards and positive terminal downwards. And this is 4-volt battery, which is already connected across the diode. Okay, so these two results we are going to use in next half cycle. So in next half cycle, we will do analysis for positive half cycle. So in positive half cycle, I'm rubbing it all. So we are having two outputs. That V output is minus 4.7 volt and VC, I think it was minus VI minus 4.7 volt. Okay, these two outputs we have obtained in negative half cycle. Okay, so for positive half cycle, our diode will be in which condition? Reverse bias condition. Okay, so equivalent circuit will be plus minus VI. This capacitor will maintain its polarity as in first half cycle. Please remember this. Capacitor will maintain its polarity as in forward bias condition when diode is in forward bias condition. Yeah, in first half cycle when we have completed our positive negative half analysis, so it was minus then plus. So I will written here, I have written here same minus and plus. This diode will be in reverse bias condition and there is a battery of minus 4 volt which is connected across this, and here we are taking our output. Okay, clear? So this again here I will be 0. So I will write a KVL starting from here and I will go towards V output. So I will write plus VI plus VC, that will be equals to V output. Okay, and now in next step I will keep the value of VC what we have calculated in first half cycle. So this V output will be VI plus VI minus 4.7. That will be 2 VI minus 4.7. And we have taken our VI as 15 volt. So it will become 30 minus 4.7. It will be 25.3 volt. Okay. So this will be my output in positive half cycle. Clear? So at last step, we will make its input output waveform. So here in positive half cycle, we are having our output that is 25.3 volt. Okay. So I'm going to draw its input output waveform. So this was my input, that is minus 15 to plus 15. This is 15 volt and this was minus 15. And as a resultant, what we get in positive half cycle, we get plus 25.3 volt, and in negative half cycle, we are having minus 4.7 volt. So this will be my output waveform. Okay, again you can check the V max minus V minimum, that will be how much? 15 minus minus 15, it is 30 volt. And here also V max minus V minimum, it is 25.3 minus minus 4.7, again it will be 30 volt. So dear all, I think with these two examples, it is clear, and I'm summarizing this. Then I will take one another circuit in which we are having our input and output. And suppose someone asks us to draw its circuit. Okay, that is the third question which are you generally asking in examination also. So I am going to summarize is the first step we have to choose that half cycle first in our diode will be forward bias condition. And most important thing before doing any analysis, first we should be confirmed that whether the question is clamper or clipper. So in clamper we will have one capacitor, number one diode will be there, and one DC battery will be there to shift its input and output level. Okay, so capacitor and one diode is essential component which must be there in any clamper circuit. Okay, then according to the question, as per the polarity of diode is connected across the DC battery, we are going to choose our first half cycle, whether it may be positive half cycle or it may be negative half cycle. Number one, then we are going to find the value of VC. That VC will remain same in next half cycle also, in which diode is in reverse bias condition. Okay, by writing the simply KVLs, we can find the our output in positive half as well as negative half. Okay, in last circuit, yeah, in next section, I'm going to discuss about suppose if input and output both are given and we have to design the circuit. For example, this is my input and they are saying that our input is varying from 2.7 volt to minus 17.3. Okay, so here the difference between maximum and minimum is 20 volt, and we have to design a clamper circuit which is having this output when we are having our input is 10 to minus 10 volt. Okay, this is my input and this is the desired output, and we have to design our clamper circuit. Means we are having our input and output both. They are asking to design a clamper circuit. Okay, so for this type of question, concentrate on lower value. So here lower value means the amplitude. I'm asking about amplitude. This is 2.7 and another one is 17.3, and our input is varying from 10 to minus 10. So obviously 2.7 will be less than 10 volt. So we should concentrate upon the lower value of output. Okay, and it is clear that in positive half cycle the output is 2.7 volt. Okay, so concentrate on this. By concentrating on this, I am drawing this that I am keeping the p-type semiconductor in upward direction, and I have connected a simple 2 volt battery across this, and this is the silicon diode. Okay, then I will make a capacitor. This will be my input, and using load resistance I will get my output. So now this is the capacitor C. So after designing this circuit, if you are gone through all lecture and you have listened carefully, obviously in positive half cycle for this circuit we will get 2.7 output, which is our output, and in negative half cycle by solving we can get 17.3 volt. So by concentrating on the lower value, we can draw easily the circuit of clamper. I will take one more example. Suppose we have given our input which is varying from minus 15 to 15 volt. This is my input. This is the circuit which we have to design, and this is my desired output. And in output, it is varying from minus 4.3 volt to 15.7 volt. Sorry, 25.7 volt. So that the here the difference is 30 volt. Here also I think difference is 30 volt. Okay. So this circuit we will have to make by using germanium diode, because germanium diode is having cut-in voltage of 0.3 volt. Okay. So as I told you earlier, we have to concentrate on lower value. So here the lower value is 4.3 volt. Okay. So I am making the circuit. This silicon diode, I will keep n-type semiconductor in upward direction. I will connect a DC battery having amplitude of 4 volt. Okay, so this DC battery overall produce minus 4 volt, and when this germanium diode will be in forward bias condition, it will be 0.3 volt. Okay, simple. I will connect a capacitor. I will write here V input, and by this circuit we will get our desired output, that will change from 25.7 to 4.3 volt, because we will analysis first negative half cycle, and in negative half cycle this voltage, this output will be 0.3 minus and minus 4, it will become minus 4.3 volt. Clear? So this will be our desired answer. So student, I'm hoping that by this duration of time you must aware about clamper, and you learn something about clamper and how to solve our clamper circuit. Okay, in next lecture we will try to discuss about parallel clipper as well as series clipper. Thank you.